Hi, hello, good morning, everyone. Kruti, Varalakshmi, very good morning. Welcome to this session. And in this session, as I said already, we are going to discuss something about why the sky looks blue and during sunrise and sunset, white appear orange or reddish color. And when we see the twinkling stars, and the stars are not at the real position, they stay at the apparent position. Why it's so, and how those are formed? So such concepts are discussed in this session. Anka, your voice is audible. Shall we start the session? Morning, Sandhya Gangotri. If my voice is audible, shall we start the session? Yeah, Kirti, good. Yeah, okay. Let me start the session. Sky will sometimes have beautiful colored rainbows, and these colored rainbows are formed in the nature, and this rainbow always have 7 colors. And this is because of refraction and total internal reflection. This is because of refraction and total internal reflection in the atmosphere. Now let me see how rainbows are formed in the nature. Before entering into this, let me see how a white light can convert into 7 colors. There is a prism here, and the white light, when it falls on the prism, it split into a band of 7 colors. A white light, when hits the prism, it forms a band of 7 into component colors, or a band of colors is called as dispersion. And who identified this kind of band of colors? This was identified by Isaac Newton for the first time when he used the glass prism. He placed the glass prism at one corner, and that light refracted into 7 colors, a band of colors, and that usually represented as whip gyre. When you see the whip gyre, it is arranged from lower side to the upper side. What is whip gyre? You take the first letters from the 7 colors, the band of colors, V, I, B, G, Y, O, R. All the first letters. Vibgayar. The first letter starts from V, that is violet. I stands for indigo. B stands for blue. G stands for green. Y stands for yellow. O stands for orange. And R stands for red. This is the band of 7 colors and it is represented by an acronym called Vibgayar. A single white light splits into a band of color called dispersion. This was identified by Isaac Newton by using a glass prism. He allowed the white light to pass through the prism, then that light split into spectrum of colors. And that is known as Vibgayar. And later, he wanted to identify, now the white light has been split into band of colors. And what happened to that white color? It is splitted into 7 colors. And where the white light has gone. So, in order to find that, he placed another prism in opposite direction. There is 7 colors called Vibgayar. Now he got a doubt where the white light has gone. It has split it into 7 colors. So again he got an idea. He placed another prism in opposite direction. All the 7 colors entered into the prism. And that colors recombined to form one white ray. Isaac Newton. Then everybody comes to know the white got 7 and that will splits in dispersion. Okay, some people having the problem with the audio, that is voice break. Morning Rekha. So all of you facing same problem? Morning Rakshita. Ravi. Tibet ma'am. Okay, ma'am has not have any problem. She is hearing very well. Okay, kid, are you sure? Will. Okay, now what to do? Let me see more maybe along with the network rectified. Okay, I'll speak out very slowly so that you can hear. Okay, I'll repeat the same session. So Isaac, the person light can split into 7 colors or into band of colors. And how he made this possible? He took a glass prism, and when the light fall on the prism, refraction takes place. What is refraction? When the light passes from one medium to another medium, the ray bends. Now you see the white light. As soon it enters into the prism, it bends. This process is known as refraction. The white light, when it enters from air medium into glass medium, now the white light is in air media and it is entering into glass medium. Definitely the medium refracts place the light. The white light has been bended. Okay, refraction took place. And what about the splitting of light? The white light has splitted into 7 colors, a band of colors. And this splitting of light into its component colors is called dispersion. Splitting of light into component colors is called dispersion. So this was identified by Isaac Newton. Now, and what about white color? Where it left? Where it went? So, in order to find out that, he placed another prism in opposite direction. He placed prism in opposite direction. Then all this about color white color ray. The light which is came out okay. I hope this concept been understood. When the light of white color when hits one prism, it splits into 7 colors and this is known as dispersion. And when we place one more prism in opposite direction, then it combines to form a white. Exact. And this is a bass into one color. The one white light splitting into 7 colors and that's 7 colors recombined into white color. This was identified by the Isaac Newton. Same this principle is applied in the formation of rainbow. The formation of rainbow. How light form. This can be explained clearly with the help of prism. When the hit this light of incidence when a light travels from one medium to another medium, definitely the light bends. So within the prism the bending occurred and meanwhile the splitting of one ray into 7 band of colors took place, and that band of colors acronym is VIBGYR. And when the ray emerges out, it will be in 7 colors. This is very essential. This concept is very essential in order to know how the rainbow is formed. Look at the band of colors. The first color is violet, and the bending of red. You just look clearly. The red always have longest wavelength. Bending is less. The violet bending is more as the wavelength is very short. Violet has got short wavelength and the red has got long wavelength. I'll repeat. In VIBGYR, the violet has got okay. Now we come to know when the incident ray hits the prism, it undergoes refraction and then it emerges out with a band of color. This was identified by Isaac Newton. Now, how this can be related with the formation of rainbow? A rainbow is a natural spectrum appearing on the sky only after rain showers. When you find the rainbows only after showers, meanwhile when you see the sun. Showers and sun together forms rainbow. A rainbow is a natural spectrum appearing naturally on the sky only after of sunlight. We see white light into known as ocean. Same thing happens in the nature. Rainbow is formed when a undergo dispersion. How the sunlight undergo dispersion? It is by the tiny water droplets present in the atmosphere. After the shower, we find a more tiny water droplets in the atmosphere. The sunlight hits this water droplets present in the atmosphere and that results in the formation of rainbow in the opposite side to the sun. That means opposite side to the white light. And what mirrors the rainbow? Now this spherical structure is called raindrop. When the ray coming out from the sunlight on the droplet, internal reflection takes place. Internal reflection. What is reflection? When a light hits a surface, it back is known as reflection. Yes, it bounces back known as Yes, reflection. Then what is refraction? Even you see refraction here. When the white light passes from air inside the water droplet, the medium changes. When the light travels from one medium to another medium, the ray will bend, and this process is known as refraction. And that bended light undergo reflection. It is not going out, it is bouncing back. That is known as internal reflection. When it goes back, that light splits into band of color. Why it splits into band of color? You just observe within the droplet, it forms a prism. It is forming a prism. So when there is a prism, a white light splits into band of colors automatically within the rain droplet. It acts as a prism, so it splits into a band of colors. And when the ray comes out, it forms a band color, that is Vibgayar. The rainbow is formed with many droplets simultaneously forming a band of color on the atmosphere. This is how the rainbow is formed on a sunny day along with the rain shower. But you don't find the rainbow when there is no showers, when there is no rain, because without droplets in the atmosphere, the rainbow is not formed. Yeah, here. Very good morning. I hope now everybody understood the concept, how the rainbow is formed. Ma'am, I used to watch your videos and I hope you're from Kerala, right? And very good nature and very good videos. And now tell me whether the concept is understood. Going so slow, you can hear without any break. Now to having problem with the audio, let me know. Okay, shall I start the session? Okay, if the concept is clear, shall I start the session? Okay, I'll go with the session. Let me see for a few more minutes. If the same problem, then we'll quit the session. Okay, how the rainbow is formed? The rainbow is a natural spectrum appearing on the sky after rain shower. It is cast where we find the rainbow. It is opposite direction to the sun. And this phenomenon takes place within a droplets. And this is the picture showing the droplet. When the white light enters inside the raindrop, it undergoes refraction, and again it undergoes reflection. While it undergoes reflection to internal reflection, then it attains a prism and it splits into a band of color. When the light emerges out, it will be in a form of band of colors. And this happens with all the droplets, and a large band of rainbow is formed in the atmosphere. And this is how the tiny water droplets, a small prisms, I can call it as small prisms, and this helps in the formation of rainbow in the presence of rain showers. Sun formed in the atmosphere. And the other concept is how the twinkling stars are not appeared at the original path, they appeared at the apparent path. Why this is so? This is because of atmospheric refraction. The rainbow is formed by dispersion. The twinkling star apparent position is due to atmospheric refraction. And what is this atmospheric refraction? Refraction of light by the Earth atmosphere. Usually the light coming from the sun, far away distance, it is traveling from one medium to another medium. And again the medium changes. I already told when the medium change, refraction takes place. When the light travels from one medium to another medium, refraction takes place. And this refraction, if it takes place in the Earth atmosphere, then it is called atmospheric refraction. And how come the atmosphere refraction takes place? It is only one medium, right? Then how it takes place in atmosphere? In atmosphere, the air usually hotter at the higher altitude and cooler close to the earth. When the hotter air is high, then it becomes very lighter, and when the air is very cool, it is very dense. Within the air, we can have two types, hotter air and cooler air. And obviously, the refractive index slightly less. And because of this changes in the refractive index, that means refractive index means the movement of the light in the medium. The speed of the movement of the light in the medium is refractive index. When compared to the hotter and cooler, the refractive index changes, and as a result, the refraction of light by the atmosphere takes place. Now I'll repeat the concept. Refractive index is the speed of the light represented with the medium. The speed of the light represented with the medium is refractive index. Now what is medium? Air medium, water medium, glass medium, etc. Now within the atmosphere, how the refractive index changes? Now I already told, by the sunlight, the air get hotter, and in some part it is left as cool air and hot air. Obviously, the hot air is lighter than the cool air. So, here we find refractive index slightly changes, and this make to undergo atmospheric refraction. This makes, that is, hotter air, cooler air in the atmosphere to undergo atmospheric refraction. Now, during night, you just see the moon. When you move, you feel like moon is moving along with you. You just see the stars. The stars will be some location, will be at some location, but we see the stars at apparent position. That is not real position, that is artificial, that is apparent position. Why this takes place? Again, bending of the light, that is refraction. And where this bending of light takes place? In the atmosphere, and that is known as atmospheric refraction. So, twinkling of stars is due to atmospheric refraction. The atmospheric refraction occurs in a medium of gradually changing due to refractive index. The star appears slightly higher. You see the image, the original position is in straight, and we are seeing the star in the apparent position in a dotted line. we see at the apparent position, but the star is slightly down. The real position is slightly down. The star appears slightly higher than its actual position because of atmospheric refraction. As the position of the star is not stationary but keeps on changing, when you have the movement along with that, the star position doesn't look stationary, it will be changing. So, twinkling of the stars, here the phenomenon is due to atmospheric refraction. And what about with the planets? Okay, this is with the stars. What about with the planets? The planets are much closer to the Earth. The planets are much closer to the Earth. And the total variation in the amount of light entering into our eye with reference to the planets is considered to be 0. So, here the twinkling effect is 0. The twinkling effect is 0. Why? The planets are much closer to the Earth rather than the stars, and hence here we don't find any twinkling effect with the planets, as the atmospheric refraction with the planets is 0. It is nullified. And what about with the sunrise and sunset delay? The sun is visible to us about 2 minutes before the sunrise and 2 minutes after the sunset. Now, I'll repeat. We'll see the sunrise 2 minutes before. 2 minutes before. Before the sunrise, we see 2 minutes early. And during sunset, we see after 2 minutes. Even after the sunset, the effect will be remained for 2 more minutes. And how? You're seeing the sun at the horizon. Horizon means horizontally. Looking at horizon. The true position is still the sun is not raised, but we could able to see it as sunrise. Why? 2 minutes before we can see the sunrise. 2 minutes before, early, we can see the sunrise. This is also because of atmospheric refraction. Because of atmospheric refraction, we can able to see the sunrise 2 minutes early. In the same way, during the sunset, already sun is set, but still we can have 2 minutes delay. Still we can see 2 minutes delay. This is also because of refraction, atmospheric refraction. I hope you all understood. What is Bhargavi saying? It's 0 in the sense. Varsha, you are not hearing the voice clearly. Voice break. Okay, very fine with Rekha. Rekha is not having any disturbance. She is so glad she wants to continue the session. Okay, Bhargavi, you can't hear. Okay, Ruksana is also there. Okay. Shall I continue the session? Everybody understood what is atmospheric refraction? And how the twinkling of stars takes place? And why we see 2 minutes early sunrise and 2 minutes delay sunset? And why the planets are not showing the twinkling effect? Okay, Arpita replying as is. So the concept is understood. Shall I go with another concept or should I repeat this once again? Okay, shall I move? Okay, I'll repeat the concept and I'll go for next one. Twinkling effect of the stars, and that is not found in the planets. 2 minutes early sunrise, 2 minutes delay sunset, all these because of atmospheric refraction. And how rainbow is formed? Rainbow is formed by refraction, internal reflection by the tiny droplets present in the atmosphere, and that is by dispersion. Atmospheric refraction, it is refraction of light by the earth atmosphere, as the atmosphere has air and the air can be hotter air and cooler air. When the hotter air and cooler air has different refractive index, definitely it results in the atmospheric refraction. When you see the star, it is slightly little bit higher than the original position. This is due to atmospheric refraction. When you see the sunrise and sunset, the sunrise, it is 2 minutes early. You can see this image. The true position is still the sunrise is not occurred, but we could able to see sunrise 2 minutes early. This is because of refraction. In the same way, sunset also. Sun is already set. That is true. Look at true position. That is sunset. Imagine it as sunset. But still we are seeing the sun. 2 minutes delay of the sunset. This is also because of atmospheric refraction. So 2 minutes early sunrise, 2 minutes delay sunset, and twinkling of the stars, all this because of atmospheric refraction. This is due to refractive index. Refractive index is due to hotter and cooler air in the atmosphere. So rainbow is due to dispersion of sunlight by the tiny water droplets present in the atmosphere. Twinkling of the stars is due to atmospheric refraction. And 2 minutes early sunrise, 2 minutes late sunset is due to atmospheric refraction. The rainbow is formed because of dispersion. And what is dispersion? A single light splits into band of color is known as dispersion. The rainbow is formed due to dispersion. This is the image showing that a white light, when it enters into the prism, it splits into band of colors, and this is known as dispersion. And this happens due to the prism. And same thing, when the water droplets present in the atmosphere will act as a prism, and hence rainbow is formed. Isaac Newton has a doubt. When the light passes within a prism, a white light converts into band of color. And when he places another prism in opposite direction, then that band of colors recombine to form a white ray. This was identified by Isaac Newton. Okay, next concept is, why is the color of the clear sky is blue? Why the color of the water in the deep sea is blue? Why the sunset and sunrise always show reddening or orange phenomenon? Now, in order to understand this concept, we have to know what is Tindal effect. What is Tindal effect? Tindal effect always shows scattering of light, but it is not possible in a clear solution. When the light is passed in a clear solution, the light emerges as it is. When the light passes in a clear solution without any scattering, it emerges out. But when you pass a light in a colloidal solution, then you find Tindal. And how we can see this Tindal in our home? You just switch off all the lights. You just on the torch from one side, let it fall on a wall. Then you can see numerous of dust particles moving, scattering in a beam of light. When a beam of light is passed, you find the scattering of light. When this can be possible? This can be possible in a colloidal particles. Scattering of light can be possible by the colloidal particles, and this is known as Tindal effect. Now, same thing happens in the sky, in the ocean, in the sunrise and sunset. The blue color of the sky, the color of the water in the deep sea, the reddening of the sun, of sunrise and sunset, these are the wonderful phenomenons, and this is because of scattering of light by the colloidal particles. This is because of scattering of light by the colloidal particles. The scattering of light by the colloidal particles is nothing but Tindal effect. The Earth atmosphere is heterogeneous mixture of tiny particles, minute particles. As we see, when you close all the doors, you just open a window, that beam of light falls on the wall and you find the particles, minute particles. That means the atmosphere comprise heterogeneous minute particles. These particles include smoke, droplets, suspended particles, dust particles, and variety of molecules of air. And when a beam of light strikes such fine particles, then we can see a clear path of a beam of light. Very clearly you can see the path of light along with the suspended particles. When the light reaches us, it is being reflected by the particles. Definitely it has been reflected by the particles. And this phenomenon is known as scattering of light by the colloidal particles. Scattering of light by the colloidal particles. And this complete phenomenon is known as Tindal effect. And how the sky looks blue. The color of the scattered light depends on the size of the scattering particles. Very fine particles of the blue light, scattered, and hence we'll see the blue color. Hence we can see the blue color. If the size of the particles is so large, then it cannot easily scattered, then definitely we can see it as a white color. Why the sky looks blue? Because of scattering of light. The molecules of air and other fine particles in the atmosphere with the small size, with the short wavelength like blue will get scattered. But the red, which is having the long wavelength, is not scattered, and hence the sky looks blue. When the sunlight passes through the atmosphere, the fine particles in the air get scattered with a short wavelength called blue. You may have the doubt, why not violet? Because first is the violet color. Why ma'am saying is blue? Why not violet? Violet wavelength is so short, so it scatters away and we cannot see the violet. And the next one is blue. The small particles which scatters the blue color with short wavelength, and they are more stronger than the violet, and hence we can see the blue but not violet. The scattering of blue light enters into our eyes, and hence we can say that the sky is blue. When we go for higher altitude, like astronauts, the people will travel in the space, they'll see the sky as black or dark. why it looks dark, as when we move at higher altitude, the scattering is not prominent. The scattering is not prominent, and hence the sky looks dark for the astronauts. I hope you all understood why the sky looks blue, because of scattering of light. The scattering of light with the short wavelength of the blue color occurs, and hence the sky looks blue. When we move at high altitude, the scattering is not prominent. The scattering is not prominent, and hence the sky looks black or dark. And one more concept, why at the horizon the sunrise and the sunset look reddish. Why the sunrise and sunset looks reddish? Here the scattering of light that helps to see the sky as blue, and now it has red during sunset and sunrise. This is because of the long wavelength of the red color is visible, as the blue and other are being scattered out. Only the wavelength with long wavelength red is appeared. At the horizon, the reddish appearance is due to the long wavelength of red is visible, whereas rest are scattered away. Only left with longest wavelength red is appeared. At noon, the sun appears white because only little of the blue and the violet gets scattered, and hence it looks white. But near the horizon, most of the short wavelengths are scattered away. Only the longest wavelength red is appeared, and hence sunset and sunrise looks reddish. Hence it gives a reddish appearance. So, scattering of the light or Tindal effect is the only phenomenon why we see the sky blue, why we see the sunrise and sunset is reddish, and why the noon is white. When we see the sky, the blue with the short wavelength get scattered, and hence sky looks blue. During sunset and during sunrise, the short wavelength almost scattered away by the particles. Only the long wavelength red is appeared. Which has got longest wavelength? Red. Red has got longest wavelength, and hence sunrise and set at the horizon will be scattered with the long wavelength, and hence the red is appeared. So in this session we come to know how the rainbows are formed. A rainbow is a natural spectrum. It is formed by the dispersion of sunlight by the tiny water droplets, where the tiny droplets act as a prisms. And in the prism, we know white light can convert into band of color. As a result, the water droplets will act as a prism in presence of sun, and thus It forms the rainbow opposite to the sun. And in this session, we come to know twinkling of the stars. We see the star not at the original position but at the apparent position. The original path is straight. The apparent path is in dotted line. So, we see the star little bit slightly higher than the original position. This is because of atmospheric refraction. What is atmospheric refraction? The refraction of light by the earth atmosphere. Within the atmosphere, how the refraction takes place? I told refraction is the bending of light when it travels from one medium to another medium. Now I am speaking only about the atmosphere. It is only one medium with the air. And how come bending takes place within the air? Due to solar energy, some part of the air will get hotter and some part will remain as cooler. So, hotter air refractive index is less compared to the cooler air. So, refractive index changes. Then the movement of the light also change. And hence, a bending takes place, refraction takes place in the atmosphere, and because of that effect, the twinkling of the star we see. And same atmospheric refraction makes us to see the sunrise 2 minutes early and to see the sunset 2 minutes delay. This is also because of atmospheric refraction. And we see the sky is blue and sunrise and sunset as a reddish. And why this is possible? This is possible by the scattering of light. This is possible by the scattering of light. And this scattering of light is due to Tindal effect. And in order to undergo Tindal effect, what is essential? Colloidal heterogeneous mixture is essential. So, Earth atmosphere will act as an heterogeneous mixture with the minute particles with smoke, dust, air molecules. All these are the reason why the Earth atmosphere show Tindal effect, that is scattering of light. Why the sky looks blue? Because the short wavelength blue is scattered by the atmospheric particles and hence we see the sky as blue. Why sunset and sunrise at the horizon appear orange or red? The short wavelength violet, blue and other colors will scattered away and now only left with the long wavelength red color. Hence, at the horizon we can see the longest wavelength red color but not short wavelength colors. As it is scattering with the long wavelength red color, hence the sunset and sunrise always looks red. During the noon, the sun appears white as only little of the blue and violet colors are scattered. Only little bit of blue and white gets scattered and hence it is completely looks like white in the noon. So this about today's session, why the sun appears orange or red during sunrise and sunset, and why the sky looks blue, and why we see the twinkling effect of the stars, and how the rainbow are formed. These are the concepts we discussed today in this session. I hope we had problem with the audio, little breaking up, and few they had no problem with the audio. They can heard everything clearly. Okay, this completes today's session. Thank you, Zia mobile app. Thanks a lot for your entry and for appreciation. Okay, I hope this session was cleared. Okay, welcome ma'am. A worm farm breeder. Welcome for this session. Okay, I hope this session was clear to everyone. Anything to be clarified here? Yeah. Very simple concepts you should remember. What is reflection? What is refraction? What is internal reflection? Reflection is bouncing back of the light when it hits the surface. Refraction is when the light travels from one medium to another medium, bending takes place. Internal reflection, when a light passes from one medium to another medium, it bends. That is refraction. And when it enters inside the medium, it bounces back within that medium. That is internal reflection. Okay. Now let me clear. And how many of you all cleared the concept and in this session? How the rainbows are formed in the nature? I need very simple answers. Either it is by atmospheric refraction or dispersion of light or by scattering of light. I am waiting for your reply. How the rainbows are formed? I'll give options. By scattering of light, by dispersion of light, by atmospheric refraction. I'm waiting for your reply. How rainbows are formed? Excellent answer, Priyanka. Yes, by dispersion of light. Excellent. Okay, my next question is, how the twinkling of stars occurs? Same options. Scattering of light, dispersion of light, and atmospheric refraction. How the twinkling of stars occurs? Okay, Revati, I hope this is for first one. This is for first one, that is dispersion of light. I already went for second question. How the twinkling of stars occurs? What, Kirti? All takes place. How come? Yes, excellent answer, Priyanka. Atmospheric refraction. Due to the atmospheric refraction, the twinkling of stars occurs. What we see, the star is not the original position. It is an operant position, slightly above the position of the star. This is because of atmospheric refraction. Yeah, Kirti, correct answer? Yeah, all the correct answers. I think Varsha answered for this. Good. And the last question. Why the sky looks blue? Why the sunrise and sunset looks reddish? I'm waiting for your answer. Why the sunrise and sunset looks reddish? Why the sky looks blue? Yes, excellent answer. It is due to scattering of light. Correct, excellent. I hope everyone understood the session. Without any confusions, you are giving out very clear answers. I hope this was little bit tough concept, but still you all answering very well. Scattering of light, very good answer. Scattering of light is nothing but Tindal effect. Good, good. Everyone answering correctly. I hope everybody understood the concepts. Anything to be clarified? Yes, Revati, Suma, Kirti, good answers. Okay, Bhargavi, spelling mistake, no problem, but answer is correct. Very good, ma. Yeah, Madhavi, Kavya, correct answer. Okay, I hope everybody understood and the session is cleared. Anything to be clarified? Okay, last question. What is the process called when the light travels from one medium to another medium, bending occurs? What is the process called when the light travels from one medium to another medium, bending occurs? What is the term given for this process? Excellent, Priyanka. Refraction. Very good, ma. Very good. That is called refraction. Very good, very good. Everyone answering correctly. Refraction. And the last question. I need correct term for this. When a light travels from one medium to another medium, the light bends, and within that medium, it bounces back. Within that medium, it bounces back. Here, bouncing back is called when the light travels from one medium to another medium. Think of water droplet. I am giving example water droplet. When the light passes from air medium to the water droplet, it bends. Within the droplet, it bounces back. What is this process called? Excellent answer, Priyanka. Internal reflection. It is not just reflection, it is internal reflection. I need the term internal reflection. Excellent. Priyanka, you are just extraordinary. You are answering excellently. Very good. Yes, excellent answer. Internal reflection. Very good, ma. Very good. Okay, the last and final question. When the light hits the surface, it bounces back. And this phenomenon is called? When the light hits the surface, it bounces back. This phenomenon is called? Good, good, good. And the last question is? When the light hits a surface, it bounces back. Very nice. Reflection. Just reflection. Bouncing back of the light is called reflection. Superb answers. Very good. Everybody answering correctly. Nowhere any sort of confusions. Very clear answers. Very clear. Very good, Revati, Chandru, Kirti, Madhavi, Kavya. Very good. Excellent, Bhargavi. So nice of you. Excellent. Bhargavi, I want to see you, ma. You just replied to me through WhatsApp. I want to see you. I'm so eager. Who is Bhargavi? I want to know who is Bhargavi. You just have a message with the WhatsApp. Okay. I thought this session is so difficult to make you all understand. I was fighting like anything. Now, how to understand, make you all understand these concepts. So clearly, you all understanding and you are responding. I hope it was cleared. No doubts. Okay, okay. 10C. Okay, okay, okay. There is one more Bhargavi from 9th. I thought that Bhargavi. Okay, okay. Fine. Very good. Very good. I'm so happy today. Very happy today because I had many doubts. Now, how to make you all clear with these concepts. So, after your response, I felt very happy today. So nice of you all. And thank you so much for your good responses. Thank you. Thank you so much. Okay. We'll meet in next session. Thank you. Thank you for attending this session. Thank you all.